Hello, good morning, everyone. So let's get started today with a warm-up question. So in this particular question, we have a car. Well, why do I always say car? No, we have an object that is moving at a velocity of -4 meters per second, and it is accelerating at a rate of 2 meters per second every second. So what would its velocity be at 10 seconds? Is it A, going to be 2 meters per second? Is it B, going to be -24 meters per second? Is it C, going to be 16 meters per second? Or is it D, going to be -8 meters per second? So which out of the four fits the question best? So for those of you just joining us, we have a warm-up question here. We have an object that is moving at a velocity of -4 meters per second, and it is accelerating at a rate of 2 meters per second every second. So what would its velocity be at 10 seconds? Is it going to be 2 meters per second? Is it going to be -24 meters per second? Is it going to be 16 meters per second? Or is it going to be -8 meters per second? Let's take another 3 minutes or so. We currently are sitting at about 12 out of 20 responses. We want to get 100%. So we are looking for another 8 more or so. 9 more, 12 out of 21. For those of you just joining us, please answer the one more question on the screen here. Figure out what would the velocity of this object be after 10 seconds. We are currently at 17 out of 21. So we are approaching the 100% goal. We're at 19 out of 21. We're almost at 100%. Let's take another 2 minutes or so to answer the warm-up question. We're at 20 out of 21. We are really close to hitting 100%. If you are the last person who hasn't answered yet, please do so. We're at 21 out of 21. Nice. We actually hit 100%. So thank you all for participating in the poll. What I'm going to do now is I am going to now start looking at this question, and then we will see what the velocity will indeed be after 10 seconds. So first off, what does it mean for a car or an object? I always say car because everything for me is a car. If an object is moving at -4 meters per second, what does that mean? So what it means is that the negative in a velocity, so velocities can be negative, and the reason why they can be negative is because it tells us which direction they are going. So in this case, we have an object here that is going to the right, to the left at 4 meters per second. So it has a velocity of -4, so which is essentially means that it is going 4 meters per second to the left or 4 meters per second in the negative direction. Now, in this case, it accelerates at a rate of 2 meters per second every second. So what does that mean? What that means is that every second, its velocity is going to get 2 meters per second faster. So if the object initially at time 0 has a velocity of -4, after 1 second, it should have accelerated by 2 meters per second. So it should have gotten to +2 meters per second faster. So after 1 second, we are looking at a velocity of -2 meters per second. After 2 seconds, we are now looking at a velocity of 0 meters per second. So notice here how every second, right, our velocity is increasing by positive 2 meters per second. So what would its velocity be at 10 seconds then? Now what we could do is we could just keep doing this little chart here. At 3 seconds, it'd be 2. At 4 seconds, it would be 4. But that seems like it's a lot of work. And we are all about efficiency here. So what is a better way of figuring this out? Well, let's see if we can try to be a little bit cleverer here. So what we know is that every second, our velocity increases by positive 2 meters per second. So after 10 seconds, our velocity should increase by 2 meters per second for every second times 10 seconds, right? So every second it's getting 2 meters per second faster. So after 10 seconds, it should get 2 meters per second times 10 faster. So after 10 seconds, it should be getting 20 meters per second faster, positive 20. Is that our answer? Are we done now? We are not done because that only tells us how much faster our velocity got in 10 seconds. That does not tell us what our final velocity is at 10 seconds. So what we want to do is we want to take our initial velocity, which is -4, and we want to combine it with the change of our velocity due to the acceleration after 10 seconds. So we initially had a velocity of -4, and then our velocity changed by positive 20. So in other words, we are taking -4 and we are adding positive 20. And so we get our final velocity should not be negative. It should be 16 meters per second. We took our initial velocity, which is -4. We figured out how much our velocity changed by, how much we accelerated by in 10 seconds, which was just 10 times 2. So we took -4 plus 10 times 2, which is 20. And then we got a final answer of positive 16 meters per second. So the correct answer is indeed C. What would its velocity be at 10 seconds? It would be 16 meters per second. So that pretty much is the gist of it. Does anyone have any questions about how you might do this particular problem? Okay, so what we are going to do right now is we are going to continue with our lesson on acceleration that we started on Tuesday. So what I want you to do is I want you to pull out your graphic organizers that we started on Tuesday. And we will continue filling those in. We are currently on, we finished, I believe, box F on Tuesday. So I believe we will continue with indeed box G, I believe, today. If you are unsure of what it looks like, or if you did not start it on Tuesday, here is the link to it. You can see what it should look like, but this is what it should look like. So try to fill it in if you haven't already. But yes, make sure that you have your own copy open. I do not have the links for your own individual ones, so you should go to Google Drive and figure those out. Okay. So once you have yours open, we will move on to the next slide. Okay. So how do we calculate acceleration? The graphs we looked at on Tuesday, they showed us that a car was undergoing some sort of acceleration because the graphs were showing us that the velocity was changing, right? If you remember the graphs we had on Monday and on Tuesday, right, we plotted a bunch of velocity graphs with respect to the time. And all these graphs here, they showed us how the velocity was changing. And if the velocity is changing, that means that the car was undergoing some sort of acceleration. Now, in order to actually calculate acceleration, we need to figure out how much the car's velocity was changing every second. So we basically need to find the rate of change of the velocity, which is just basically another way of saying slope, right? So which is just basically saying if we want to find the acceleration of a velocity graph, we want to find the slope, or we also want to find how much the velocity was changing every second. So for example, if we looked at this graph right here, what we found was that the velocity was changing by positive 13 meters per second every second. So initially, the velocity was 0. After 1 second, the velocity was 13. After 2 seconds, the velocity was 26. So every second, the velocity was increasing by positive 13 meters per second. So what we could say is we could say that the car, the Model S, had an acceleration of 13 meters per second squared, which means that every second, the Model S's velocity would increase by 13 meters per second. So if Mike's car is getting faster by 13 meters per second every second, that means that the car has an acceleration of 13 meters per second squared, meaning that every second the car's velocity would increase by 13 meters per second. Now, this tells us how fast the car's velocity is changing. It does not tell us how fast the car is actually moving. It just tells us that the car is getting faster or getting slower by some amount every single second. So the units we use for acceleration are meters per second squared. So meters divided by second squared. And this is pronounced meters per second squared. So make sure you write down what the units for acceleration are, and make sure you should also write down how they are pronounced, so that way you are sort of understanding what this means. So these are the units for meters per second squared. Note that we have different units for acceleration compared to our velocity units. Our velocity units use meters per second. Our acceleration units use meter per second squared. There is a difference there, and that difference can tell you whether or not you are looking at an acceleration or if you are looking at a velocity. So now that we sort of have an idea of what acceleration means, how we might calculate it, what the units are, and how we might use these units, what we are going to do now is we are actually going to try to figure out what our velocity is at different points in time. So what I have here is a particular problem here. An object starts with a velocity of 20 meters per second, and it decelerates at a rate of -4 meters per second squared. So an object starts with a velocity of 20 meters per second, and it decelerates at a rate of -4 meters per second squared. What we have here is we have a table with our times on the left column, and what we want to do is we want to figure out what is the velocity of the object at every point in time. So what is the velocity of the object when time is equal to 0? What is the velocity of the object when time is equal to 1, etc., etc.? The last one tells us what is our velocity at any arbitrary time, at any arbitrary t. Basically, you're trying to write an equation that allows us to find the velocity using the variable t instead of a number. So that is going to be the challenge. That's our goal here, is to be able to figure out fill out this table and see if we can fill out the last row. So I'm going to put you into your breakout groups, the ones that you always work with, and then I will let you try to figure out some of these numbers. So in 5 minutes or so, try to fill out this table with all of your particular velocities for each time. Okay, so I'm going to go over this table right here. So let's take a look at this table. What would be our initial velocity? So the velocity we are starting with is 20. After 1 second, our velocity drops by -4. So this should be, sorry, this should be 16. After another second, it goes down by another 4. It should be 12. After another second, it should go down to 8. Another second, it should go down 4. So as you can tell here, every single second, our velocity is changing by -4. Right. That's because it's decelerating at a rate of -4 meters per second squared, which means every 1 second, your velocity is going to be changing by -4, or it's going to be decreasing by 4. Now, how might we figure out what our velocity is at 10 seconds? Now, one strategy that we could use is we could just keep counting down to 10, because 10 is not that far from 4. But I think that it's probably maybe not the most clever strategy we can come up with. I think we're going to try to figure out a pattern here that maybe allows us to figure it out. So what we know is that no matter what happens, our initial velocity is always going to be 20. That is how fast we were initially going. And what we do here is we figure out how much did our velocity change after that amount of seconds. So in here, in the first second, our velocity changes by -4 total. In the second second, it changes by -8 total. In the third second, it changes by -12 total. So what we can say is that our velocity at any time is our initial velocity, right, plus how much it changed by. So in 10 seconds, what we expect is the velocity to change by -40, right? So if in 1 second it changes by -4, in 2 seconds it changes by -8 total. That means in 10 seconds it should change by -40 total. So that means that our velocity at 10 seconds should be -20. So how might we sum this up in an equation for any time with the variable t? Well, it's the same idea here, right? Our velocity at any time is going to be our initial velocity, which is 20, plus how much our velocity changes. How much our velocity changes is our rate, which is 4 meters per second every second, 4 meters per second squared, times the time. So -4 times t tells us how much did our velocity change by in that amount of time. And then we combine that with our initial velocity to figure out our final velocity at that particular time. So our equation will just be 20 minus 4 times t. What I want you to do now is we have a graph of velocity and time. And I choose you, to figure out the acceleration of this graph. Have you done this before? Yes, you have. But the terminology we're using is a little bit different. We're saying find the acceleration. You know how to do it, but the terminology is a little bit different, so it might be a little weird. So yeah, go into groups here, try to figure out the acceleration of the graph.
Did you guys get kicked out?
Alrighty, so let's take a look at this graph here and let's see if we can figure out what the acceleration is. So when we want to find our acceleration, what we're looking for is basically how much is our velocity changing. We're basically looking for a change in our velocity. So in this graph, if we look at it, we can see that every 2 seconds, it goes up by 1. So every 2 seconds, our velocity goes up by 1. Or it's just another way of saying that every 1 second, our velocity goes up by 0.5. They mean the same thing, right? So basically, our velocity goes up by 0.5 meters per second every second, which if we were to sort of our velocity basically goes up by 0.5 meters per second every second, which is just basically saying that our acceleration is indeed 0.5 meters per second squared. So that's one way you can take a look at it. Another way you can take a look at this is what if we, right, because we want to try to, we're trying to measure a rate of change, right? And so what else is a measure of the rate of change? The slope is a measure of the rate of change. So if we take a look at the slope of this graph, our slope is our rise over run. So our rise is 1 and our run is 2. And so we get that our slope is 0.5. No way. Our slope is the same as our acceleration? What? That makes no sense at all. But it does make sense because our acceleration is really just measuring the rate of change of our velocity. And so another way of saying rate of change is really just saying the slope. So we can look at how much time it takes for our velocity to go by 1. That's one way to do it, which is the first way we did it. Or we can also just take a look at the slope, right? If we have a velocity versus time graph, we can also just take a look at the slope to try to figure out our acceleration. So overall, I'm really proud of you guys. You guys did a really good job here. What we are going to do next is we are going to take a look at another graph. I mean, this is the same graph. Sorry, apologies, same graph. But what I want you to do is I want you to write an equation for this graph. What do I mean by this? So here is our goal. I want you to let me explain what we're trying to do here. So in general, right, if we would write an equation for a graph like this, we would use the general format y is equal to mx plus b, right? We have a general equation for any sort of line graph. We're going to use the equation y is equal to mx plus b. Now for physics, for acceleration, right, these variables, right, y, m, x, and b, don't make a whole lot of sense because we can try to use more specific variables that might be a little bit more helpful to look at. So instead of using y, m, x, and b, what we want to do is we want to use these 4 variables. Our final velocity, which we call vf, our initial velocity, which we call vi, our time, which we call t, and our acceleration. So what I want you to do is looking at this graph here, using this as a general idea, I want you to try to replace this equation, y is equal to mx plus b, with these 4 variables. So each one of these variables, y, m, x, and b, I want you to try to replace these with these variables. So Viviana has done a great job here. But Viviana, she helped us find the equation for this graph, which is y is equal to 1/2 x plus 1, right? 1/2 is our slope, which is our m. And then our b is our y-intercept, which Viviana found was 1. So thank you, Viviana. So she gave us a specific equation for this graph. What our goal here is to let's see if we can try to convert these equations into using these variables. So I want you to figure out, how can we replace these 4 variables with these particular names, vf, vi, t, and acceleration. So we want to try to replace these variables with these ones. So that's what we are going to be doing for the next 5 or 10 minutes or so. Let's see if we can try to derive a general equation for acceleration and velocity and time using these 4 variables in the general equation. So I'm gonna put you in your groups again, and then let's see if we can figure this out. Okay, so let's talk about what to do here. So what is the equation we're working with? Okay, so what we have to do is we are trying to replace y is equal to mx plus b with these four variables. So how might we do that? So first off, what is the y-axis of this graph measuring? Well, this y-axis is of this graph, right? It's measuring our velocity. And more specifically, it's measuring our final velocity, our velocity at that point in time. So we are actually measuring our y is actually measuring our VF. Thank you, Viviana. Great job, Viviana. So our y-axis, our y values is measuring our final velocity at that point in time. And so that would be our VF. Now, which one do we want to go next? So usually there's a few other ways of going, but you know how we looked at the y-axis? So why don't we look at the x-axis first as well, second. So what is our x-axis measuring? Our x-axis is, just like our y-axis was measuring our velocity, our final velocity, our x-axis is indeed measuring our time, right? It's measuring our time. Thank you, Viviana. So instead of x, we're going to use t. Instead of y, we're going to use VF. Now we have a 50-50 shot here. We have a B and we have an M left. We have a 50-50 shot here, but I don't believe in gambling because gambling's not good. Let's see if we can actually mathematically work this out. So B is our y-intercept of a graph. And what does a y-intercept mean? A y-intercept is basically a starting point. What does our velocity start off with? So in this case, our velocity starts off with a 1. So is it acceleration or is it not acceleration? Could be. We're trying to figure out which one it is. So what this case here, what we are trying to do is we're trying to figure out what is our starting point, right? What is our B? What is our starting point? Well, initially at 0 seconds, we are starting off with a velocity of 1. So at 0 seconds, our y-intercept, our starting point, is a velocity of 1. So we're starting with a velocity of 1. What's another way of saying start? Initial. So maybe instead of saying our y-intercept, maybe instead of saying our starting velocity, we can use the terminology initial velocity. So we can replace B with our VI. So that leaves one left, our M. What does M usually mean? M usually means our slope, right? And our slope is just another way of saying rate of change. In other words, how much is my Y changing every X, right? So we are trying to figure out how much is my velocity changing per time. I'm basically measuring change in velocity over change in time, because that's what our slope is. That is what our slope is. What's another way of saying a change in velocity over a change in time? Another way of saying this is just our acceleration. This is what acceleration means. Acceleration means our rate of change of velocity over the rate of change in time. In other words, our acceleration is our slope of a velocity graph. So now we have successfully replaced y is equal to mx plus b with this equation. Vf, our y, it used to be y, is now Vf. Our m is now a, our x is now t, and our b is now vi, our initial velocity. So what does this look like in non-crappy annotation drawings? With a nice professional slide, this is what it looks like. The general equation that relates velocity to time is that our final velocity, our VF, is equal to our starting velocity, VI, plus how much it changed. In other words, plus A times T, because A measures how much our velocity changes per second, and then T tells us how much seconds our velocity changed by. Notice how this equation is the same format as Y is equal to M times X plus B. Notice how the two formats here are the same. So really, we're just taking our y is equal to mx plus b, and we're just replacing it with vf is equal to vi plus a times b. So this equation is going to be the backbone of a lot of the stuff we're doing this unit. So make sure you write this equation down. But not only should you write this equation down, you should also write down what each of these variables mean. Because if you're looking at this equation and you're trying to use it and you don't remember what VF is, you want to have a place to write it down. So that way you can refer back to your notes and see that VF is really just our final velocity. VI is our initial velocity. T is our time, A is our acceleration. So make sure you write this down. You came up with the equation A is equal to VF minus VI plus T. Is this also correct? If you what happens if you add VI over T to both sides? Oh, hold on. It's is it Oh, yes, 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 yes. That is also correct. Yes, 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 yes. That's actually a really interesting way of, yes, that is 100% correct. So another way of writing this is that A is equal to our change in our velocity. So our change in velocity over time. So our A is equal to VF minus VI over T. Yes, this is excellent. This is actually another great equation. I actually probably should have also given you this as well. So thank you so much for showing me what you came up with as well. So another way of saying what our acceleration is, or our acceleration, right? It measures our change in velocity, right? Change in velocity over our change in time. Because we're measuring our slope, right? So what is another way of saying our change in velocity? Another way of saying change in our velocity is our final velocity minus our initial velocity over time. This will equal our acceleration. So this is another way of writing the same equation that is also probably, honestly, probably makes more sense than the one I have. So this is also another great equation of writing down. So I would actually highly encourage you to write this down. So thank you so much for coming with this one up. This is actually really good. I think that shows a lot of really high level thinking here. So I'm actually very proud of you. This is a really good equation to also know. I'm very glad you're able to come up with it. So yes. Yep, that is also correct. So this is also another good equation, and this is a good one. So this is the same equation as this one, just with stuff rearranged a little bit. But this one gives you a better idea of what acceleration means. So it's just a change in velocity over time. And this one is a better equation for looking at if we're trying to figure out what our final velocity is. Right, this one's probably makes a little bit more sense. And if we want to figure out what our acceleration is, right, this one probably makes a little bit more sense. So these are the same equations to use, just a little bit different formats, but these are really good, really good. So very high level thinking. I think I might actually ask you in a second how you came up with yours. It's really clever, and I would love to hear it. But for now, I'm just going to share what you gave me. So yes, excellent equation to come up with. Okay, so now that we have these two equations, well, the same equation, the two equations to work with, what we can do now is we can actually try to solve some practice problem. So for our first practice problem here, a motorcycle accelerates from 10 meters per second to 50 meters per second in 4 seconds. So what is the bike's acceleration? The motorcycle accelerates from 10 meters per second to 50 meters per second in 4 seconds. What is the bike's acceleration? So we're going to try to figure out the bike's acceleration. I'm going to put you in your breakout groups. We're going to take a few minutes to try to work out this problem, and let's see what we get in a few minutes. I am going to quickly go over the first practice problem, and then we're just going to try to knock out the exit ticket, and then you're free to go. So let's just knock out the first one. So for the first one, what information are we given? So we are given a initial velocity of 10, initially moving at 10. Our final velocity is 50, because we're ending with a velocity of 50. And it takes us 4 seconds to go to do that. And we want to find our acceleration. We currently do not know. So how might we solve this? What we're going to do is we're going to use the equation that we came up with. Bf is equal to Vi plus AT. Our Bf is 50 is equal to 10 plus A times T. Okay, we just plug these in. So we subtract 10 from both sides, so 40 is going to equal A times T. T is 10, or T is 10. And then so that means our T should be, our A should be 10 meters per second. So that's just pretty much it for the first practice problem. I just want you to quickly knock out the exit ticket, and then once you finish that, you are free to go. Yeah, and then submit your graphic organizer whenever you are done.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye, Miles.
Bye. Thank you.
Bye, Adriana.